talking about BGP attributes and path selection from NetworkLessons.com. BGP routers usually receive multiple paths to the same destination, like how our IGPs work. We need to select the best path to each destination.
Hey there, this is René for Network Lessons. In this video, I'll give you a quick explanation of how BGP best path selection works. Now, when you think of our IGPs like OSPF, RIP or eIGRP, there's two things that they have in common. They all want to find the shortest path to each destination. Like RIP uses a hop count, OSPF has its cost, which is based on the bandwidth of an interface, and eIGRP uses the bandwidth and delay to calculate a composite metric. Now, the second thing they have in common is that we use them on our local area networks. Now, BGP is a bit different. It was created for routing on the internet between autonomous systems. So let me give you an example. Let's say that this is a small part of the internet. We have 5 autonomous systems, and I'm the administrator of AS1. Now, let's say that I want to get to some destination in AS5. Let's call it destination X. Now, there's a couple of options I have. From AS1, I could go through AS4 to get there. I could go through AS2 and then to AS5. And I could go through AS2, then through AS3, and then go to AS5. Now, on the internet, the shortest path is not always the best option. Maybe I have a better relation with the guys from AS2 compared to AS4, which is why I want to send all of my traffic through AS2. Something else that I might want to do is, if you look at AS1 and AS4, I have 2 interfaces, 2 links in between. Maybe I want to use this link over here to get to destination X, and maybe I have, let's say we have destination Y in AS5, and I want to use the other link to get to destination Y. That's something that is very easy to do with BGP. Also, for my incoming traffic, I could inform AS4 that I prefer to use this link for all of my incoming traffic. So from AS1, I can do something with BGP to inform AS4 that they should use the second link to send traffic to my autonomous system. That's something that is easy to do with BGP. Now, to achieve this, we need something that is a bit more advanced than just a simple metric. So what BGP does, it uses a big list of attributes. These are all the attributes that BGP has, and it uses these as a tiebreaker. So let's say that I have a couple of BGP routers. So let's say that we have something like this, and we have a destination over here. I'll call it destination X again. And that means that the router on the left side could go like this. That's one path. Or it could go like this. So if it has 2 different paths that it could take, then what it does is that it will compare the attributes of these 2 paths. Now, how it works is that it will start at the top. And the first attribute is the weight attribute. So it will compare the weight attribute of these 2 paths. And if one of the 2 paths has a better weight attribute, then that's the path that will be used. That's the best path. And that's what we are going to install in the routing table. Now, if these 2 paths have the same value for the weight attribute, then we're going to skip it. And we're moving to the second attribute, which is called local preference. We compare it, see if we can use it as a tiebreaker, and if not, we go to the next attribute, which is called originate. We compare it. If one of the two paths has a better originate value, then that's the one that becomes the best path. If not, we continue and we go to the next attribute. And this continues until we end up at the neighbor IP address. That's something that will be, it's always unique. So that's something we can always use as a tiebreaker. Now, what these different attributes mean, like wait, local preference, originate, that's something that I will cover in different lessons. So all these attributes, they work differently. They do different things. That's something that I will explain in other lessons. But I hope that this video has been useful to understand a bit how BGP selects the best path, the attributes that we have, and yeah, that's it for now. So take a look at some of my other videos where I explain these attributes in detail. For now, thank you for watching, and till next time.
This video is not over for some reason. Like, is it just... I think he was kind of lazy, so he forgot to edit this and cut off the remaining. Anywho, IGPs. Interior gateway protocols select the path with the lowest matrix, such as RIP with the lowest hop count, OSPF with the lowest cost, EIGRP with the path that has the highest bandwidth and the lowest delay, unless you change the K values. I don't know anything about that. Who uses EIGRP? Moving on, BGP, however, selects the best paths based on a list of attributes. On the internet, it's more important that you have a granular control over how you forward traffic, and to which autonomous systems, instead of going for the shortest path based on a metric. If we look at this example, he's looking at a looking glass server. Looks like he has many paths to the 1/24 network, and looks like the one with this greater than sign is the best. This BGP router has 5 paths for the network 1/24. Look at the greater than symbol at the bottom left. The greater than symbol means that BGP has selected this path as the best path. This path will be installed in the routing table. Out of all those 5 paths, why did BGP select the path? Why did BGP select this path as the best path? So, we're going to look at some attributes. This is, as he mentioned in the video. Let me give you a quick overview of each attribute, okay? So first we have weight, and BGP will prefer a route or a path with the highest weight. This is the value that is local to routers and it's Cisco proprietary. The default value is 0 for all routes that are not originated by the local router. You can learn how it works in the next lesson. Then the next attribute we have is local preference. The local preference is used within an autonomous system and exchange between IBGP routers. We prefer the path with the highest local preference. Default is 100. And then he will review this over a different lesson. Then we have the originate attribute. Prefer the path that the local router originated. In the BGP table, you will see next hop 0.0.0.0. You can get a path in the BGP table through the BGP network command, aggregation, or redistribution. A BGP router will prefer routes that it installed into BGP itself over a route that another router installed in BGP. Okay, so if it's like a connected route, or if it's a static route, or possibly if it's something that came from IGP, then that would have precedence over something that is learned in BGP through the network command aggregation and redistribution. We'll find out. The next attribute is AS path length. So this is going by hop count. So how many autonomous systems does it take to get to the destination? The longer it is, the less preferred. Then we have origin code. There are 3 origin codes: IGP, EGP, and incomplete. IGP is lower than EGP, and EGP is lower than incomplete. Guess we'll figure out what this is in another lesson. And then there's the multi-exit discriminator, which is exchange between autonomous systems. And there's a lesson on that. Next is eBGP path over iBGP. Prefer external BGP over internal BGP paths. And next one, shortest IGP path to BGP next hop. Okay. Prefer the path within the autonomous system with the lowest IGP metric to the BGP next hop. We have oldest path. Prefer the path we receive first. In other words, the oldest path. Then we have router ID. So whoever has the lowest router ID will win this tiebreaker. Wait a second. This says the router ID is based on the highest IP address. Oh, of the router. Or is it? If you have a loopback interface, then the IP address on that loopback interface will be used. The router ID can also be configured manually. Oh, it's still talking about the router ID, and this is saying what your router ID is by default before looking at loopback interfaces. Next attribute we have is neighbor IP address. Prefer the path with the lowest neighbor IP address. That should be unique. What's path selection? That's not part of the attribute list, is it? No, it's not. Path selection. When BGP has multiple paths to a destination, they are stored in the BGP table. All paths are in the BGP table, but only one gets installed in the routing table. Which path do we select? We start at the top of the list, and we work our way to the bottom. We start with the weight because it's at the top. We now have 2 options. One path has a better weight, then we select this path. If the weights are equal, we move down. The next attribute is local preference. Same thing, same routine. And then, yeah, this is basically what he said in the video. If it boils down to the neighbor IP address, then there's going to be definitely a tiebreaker because the IP addresses should be unique unless there's something wrong with the network. But yeah, I hope this lesson has been useful. Cool. I'm gonna end this session and start up another one for the next lesson, which is a BGP weight attribute. Thanks for watching.